This is going to be the final example on inclined planes. So we've got a particle P of mass 2 kilograms moving on a slope and being acted on by a force of 4 newtons that acts parallel to the slope as shown. The slope is inclined at an angle of alpha to the horizontal where tan alpha is 3/4. We want to work out the acceleration of the particle. Okay, so we've got a bit of the diagram given to us already. We're going to need to add a few more things. So we want to add on the weight of the particle. So it's got a mass of 2 kilograms, so its weight is 2g. We've also got reaction force, and because we're dealing with an inclined plane, we're going to end up resolving parallel and perpendicular to that plane. So I'm going to get the components of these already. So this is alpha, the angle here. This is the adjacent side, so it's 2g cos alpha. This is the opposite side, so it's 2g sine alpha. So the acceleration is up the plane. So let's label that as a meters per second squared. Bear in mind, I'm assuming it's going up. If I'm wrong, it won't matter, because all that will happen is that we'll get a negative answer for the acceleration, and that will be telling us that it was actually accelerating down the slope. Okay, so we're going to resolve parallel to the slope. So if we're going up the plane, we're going to have the 4 newtons is pushing us up, the 2g sine alpha is pushing us down. So 4 take 2g sine alpha is equal to the mass, which is 2 times the acceleration a. Okay, so it looks like we've got two unknowns there, a and alpha, but we're told tan alpha is 3/4, so from there we should be able to work out what sine alpha is. So with this sort of question, I wouldn't want you to do inverse tan and then sine it. What we want to do is do it as a little triangle. So we're told that tan alpha is 3/4, so tan is opposite over adjacent, so opposite adjacent, so the opposite is 3, the adjacent is 4, and I can just use Pythagoras to work out that the hypotenuse is 5. Hopefully you recognise a 3, 4, 5 triangle anyway, but you could do 3 squared, 4 squared, square root of that is 5. And then sine alpha is the opposite over the hypotenuse, so it's 3/5. And then we can substitute that into the equation we just wrote down. So 4 take 2g times 3/5 is equal to 2a. So 4 take 6/5 g is equal to 2a. So a is 2 subtract 3/5 g. And I suppose we ought to substitute in g to be 9.8 to then get some kind of approximation to that. So we're going to do 2 take 3/5 times 9.8. And we get a minus, so we get minus 3.88 meters per second squared. So as I said, if we've got a minus, it wouldn't mean that we're wrong necessarily, it just means that it's going in the opposite direction. So we can say that the acceleration is 3.88 meters per second squared, and I'm just going to put down the slope. And that's it.